Ah, the moon, a celestial body that has inspired humanity for millennia. It's been the subject of poetry, songs, and yes, some pretty wild theories. Is it made of green cheese? Could it be hollow? Why is it so perfectly positioned to create solar eclipses? And, is it secretly an alien spaceship? Now I know what you're thinking. Alien spaceships? Really? Hey, I'm a scientist. I'm all about exploring every possibility, no matter how improbable. But we're going to ground these theories in some good old-fashioned science. We'll separate lunar fact from fiction, and who knows, we might even uncover some surprising truths along the way. Let's break it all down in this 10-minute lunar adventure. Let's start with the most pressing question. Is the moon made out of green cheese? This idea, of course, comes from a very old European folktale. You know, back when people thought the Earth was flat and the stars were just tiny pinholes in the night sky. But let's be clear, the moon is not made of dairy. No. We've sent probes, we've landed humans on it, and I can assure you there's not a single cheddar crater in sight. In reality, it's primarily composed of rock, lots and lots of rock. We're talking about anorthosite in the highlands, basalt in those dark flat maria. That's Latin for seas, by the way, because early astronomers thought those were bodies of water. The moon's surface is covered in regolith, a fancy word for lunar soil made of crushed-up volcanic rock and dust. This stuff is the result of billions of years of meteorite impacts, pulverizing the surface into a fine powder. Now I know what you cheese enthusiasts are thinking. Maybe, just maybe, there's a core of green cheese deep inside, hidden beneath all that rock. Well, I hate to break it to you, but the moon's interior is far too hot for cheese, green or otherwise. We're talking about temperatures exceeding 1,000 degrees Celsius. Any self-respecting cheddar would be a puddle of molten goo at that heat. So, while the green cheese theory makes for a fun story, the reality is far less cheesy, but no less fascinating. Next up, is the moon hollow? This theory gained popularity after seismic experiments conducted during the Apollo missions. When astronauts intentionally crashed a lunar module onto the moon, it rang like a bell for almost an hour. Sounds spooky, right? Like a giant gong echoing through space. Now I can see how this would get the conspiracy theorists buzzing. A hollow moon? It's like something straight out of science fiction. But before we jump to conclusions about secret alien bases inside the moon, let's look at the science. Scientists have since explained this phenomenon. You see, the moon's crust and mantle conduct seismic waves differently than Earth's. Our planet has a lot of water and active geology which dampens vibrations. The moon, on the other hand, is much drier and geologically quieter. Think of it like this. Imagine ringing a bell that's submerged in water versus ringing it in the air. The bell in the air will ring longer and louder because there's less to muffle the sound waves. The same principle applies to the moon. The lack of water and active geology allows seismic waves to travel much farther and reverberate longer. But that doesn't mean it's hollow, it just means it's got a different kind of ring to it. Think about it. If the moon were truly hollow, it wouldn't have the gravitational pull to influence tides here on Earth. And let's be honest, messing with the tides is kind of the moon's thing. The moon is huge compared to other moons in the solar system. It's about 1/4 the size of Earth, which is unusual. Most moons are tiny compared to their planets. Look at Mars, for example, with its little potato-shaped moons, Phobos and Deimos. Those are practically asteroids compared to our moon. So why is ours so big? The leading theory, and the one that gets me most excited, is the giant impact hypothesis. Now this is where things get really interesting. Picture this. Billions of years ago, the early solar system was a chaotic place, a cosmic billiards game with planets and protoplanets constantly colliding. And in this particular game, Earth got a little too close to a Mars-sized object, which we call Theia. Theia wasn't just passing by though, it slammed into Earth with a force that's hard to even imagine. We're talking about an impact that would make the asteroid that wiped out the dinosaurs look like a pebble. The debris from this massive impact, a mixture of Earth's mantle and Theia's remains, was flung out into space. But here's the thing, gravity is a powerful force. Over time, this debris, bound together by gravity, coalesced, cooled, and formed the moon we know and love today. Now this theory isn't just a shot in the dark, it explains a lot about the moon's composition. See, the moon's rocks have a remarkably similar composition to Earth's mantle, which supports the idea that they were once part of the same celestial body. Chapter 4. Perfect solar eclipses. Coincidence or conspiracy? Here's another mind-blower. During a total solar eclipse, the moon fits perfectly over the sun. blocking out its light and creating one of the most awe-inspiring spectacles in nature. How is that possible? It's like the universe's own cosmic clockwork, with two celestial bodies aligning perfectly. Now, some folks might see this as evidence of some grand design, a cosmic conspiracy. But I'm here to tell you, it's all about the math, baby. And trust me, the math is beautiful. The sun is about 400 times farther away from Earth than the moon. That's a pretty significant distance, right? But here's the kicker. The sun is also about 400 times larger than the moon. This perfect ratio, this cosmic coincidence, creates the stunning eclipses we see. Think of it like holding a dime up to the sky, blocking out the light from a much larger object, like a distant streetlight. The dime and the streetlight haven't magically shrunk or grown. It's just a matter of perspective and distance. And let me tell you, these eclipses aren't just pretty to look at. They've been instrumental in scientific discoveries. For example, during a solar eclipse in 1919, astronomers were able to observe the bending of starlight around the sun, confirming Einstein's theory of general relativity. So these celestial alignments aren't just beautiful, they're downright groundbreaking. Chapter 5. Is the moon an alien spaceship? Let's dive into the wildest theory of all. Is the moon an alien spaceship? This idea comes from conspiracy theorists who point to its strange orbit and unique properties. They argue that the moon's near-perfect circular orbit and its position relative to Earth suggest it might be an artificial object, carefully placed there by some extraterrestrial intelligence. Now, I appreciate a good alien theory as much as the next person. After all, the universe is a vast and mysterious place, but extraordinary claims require extraordinary evidence. And when it comes to the moon being an alien spaceship, the evidence just isn't there. First of all, we've studied the moon extensively. We've landed probes on it, collected samples, and even walked on its surface. And guess what? It's made of rock, just like we'd expect a natural celestial body to be. No signs of warp drives, no alien control panels, no hidden messages from extraterrestrial civilizations. Secondly, the moon's orbit, while relatively circular, isn't that unusual. Many moons in our solar system have near-circular orbits. It's a natural consequence of gravitational interactions between a moon and its planet over billions of years. And as for the moon's position relative to Earth, well, that's just the way the cosmic cookie crumbled. The early solar system was a chaotic place, with planets and moons forming and migrating over millions of years. The moon's current position is simply the result of these ancient gravitational dances. So, while the idea of the moon being an alien spaceship is a fun one to entertain, it's important to remember that the simplest explanation is usually the right one. And in this case, the simplest explanation is that the moon is a natural satellite, formed billions of years ago, just like countless other moons throughout the universe. Chapter 6. Why we love the moon. Whether it's made of cheese, hollow, or the remnant of a cosmic collision, the moon is undeniably fascinating. It lights up our night sky, causes the tides, and sparks our imagination. It's been a source of wonder and inspiration for poets, artists, musicians, and scientists for centuries. Think about it. For millennia, humans have gazed up at the moon, wondering about its mysteries, telling stories about its origins, and using it to track time and navigate the seas. It's been a constant companion throughout human history, a silent witness to our triumphs and failures. And let's not forget the sheer beauty of a full moon illuminating a clear night sky. It's enough to make anyone stop and stare in awe. It's a reminder of the vastness of the universe and our place within it. The moon also plays a crucial role in life on Earth. Its gravitational pull creates the tides which have shaped coastlines, influenced marine life, and even played a role in the evolution of life itself. And while we may not know everything about it, one thing's for sure: the moon isn't just a rock. It's a key part of what makes life on Earth so special. It's a celestial neighbor, a cosmic dance partner, and a source of endless fascination. So the next time you look up at the moon, remember that you're looking at a celestial object that has captivated humanity for millennia, a source of wonder, inspiration, and scientific discovery. Keep looking up. Thanks for joining me on this lunar journey. We've debunked some myths, explored some mind-blowing theories, and hopefully gained a deeper appreciation for our celestial neighbor. If you love this dive into moon myths and mysteries, hit the like button, subscribe, and let me know in the comments what you'd like me to explore next. Black holes? The search for extraterrestrial life? The possibilities are as limitless as the universe itself. Until next time, keep looking up.